Let's talk about securing our function. There's many ways to do that. As such a function is essentially just a C# code base, in our case, you can manage all of that in code. That typically means validating an incoming key or an incoming token. You can do that in the function body directly, as via the HTTP request that's incoming, you have access to the full request, including headers related to authentication that may contain a token, or query string parameters that may contain an API key or something along those lines. But you might as well take this token or key validation logic and put it in a small custom piece of middleware, which you execute whenever the request comes in, before the actual function body is reached. But that would still mean doing all of that inside of your codebase. What I want to do is take that management and validation out of the codebase and onto the Azure platform. After all, this is an Azure for Developers course. Let's open the function again. At this level, we can define the authorization level. It's currently set to anonymous. Depending on what this is set to, this will trigger the hosting platform, our function app in this case, to execute a specific type of key validation logic. Anonymous is what we've used up until now. Obviously, that allows anonymous access. Function level access allows access to requests that include a function key. These are keys that will only allow access to one specific function inside of our function app. So it is tied to, for example, this getItineraries function. This is easy to use and allows individual functions to be secured. Moreover, if the key is compromised, only access to one specific function is compromised. That being said, seeing this key is tied to one specific function, it also means more key management. When you set the authorization level to function, another key also allows access, the host key. A host key provides access to all functions in the function app, so a broader level of access, but also a potentially broader level of risk. Also, less key management. Then we have the master key. That's a type of key that provides access to the function app, plus all potential runtime REST APIs. It grants an extensive level of access, and it cannot be revoked. It's mainly useful for management tasks, as via the REST endpoints you gain full control over your function app resource as well. So not only over the functions inside of that app resource. I would advise against using this approach for function endpoint security. Lastly, you've got system keys. These are used by Azure functions for specific bindings, for example when using an event grid trigger. They cannot be managed by users and are really only here for internal components. We won't use them for our HTTP trigger. So what I'm going to do is set this to function and publish this again. Our function was published. Let's try getting the itineraries. And this immediately fails with an HTTP error 401. Unauthorized, in other words. This is because we didn't provide a function or host key. But where can we find those? Well, over on our function app, there's an app keys blade. Here we can find the master key, which was the one that we did not want to use, and we can also find the default key. This is the host key that allows access to all functions. So let me show the value and copy this, and let's send that request again by passing through that key via a code query string key value pair. And there we go, we have access again. You can only have one master key, but you can define additional host keys if needed. You can do that by clicking New Host Key here and filling out a name and value. These keys are encrypted at rest and they are by default stored in the blob storage container that is linked to the function app. System keys, as mentioned, cannot be managed by us. If you have a system key that allows access to a function, you'll be able to find them on top here as well, but you won't be able to change them from here. That leaves us with the function keys themselves. Let's open the overview blade. And let's click the Get Itineraries function down here. This brings us to a page where we can find keys related to this function, so keys that would allow access to this function by clicking Function Keys here. These can be created, renewed, and removed, and they are passed through to the function via the query string with key code. So let me just copy this key and let me paste it in here instead of that previous host key. And there we go, this too allows access. So this is a valid approach when your functions are public endpoints that need to be somehow secured. Later on in the course, we will see that we can also secure access to a function app with a managed identity. But for that, we will need another service that will use a managed identity to call the function app. That will be a logic app, but that is coming up next. For now, this is sufficient. Now, while we're on this function detail page, let's learn how we can test and monitor this function in a bit more extensive way than we have done up until now. If you're testing functions and you need to know which key you can use, you can look for them as we just did. But another good approach is to go to the details of one function, then go to the Code plus Test tab and then choose to get a function URL. This gets you the URLs for accessing the functions using the master key, the default, so the function key, or the host key. Slightly easier than what we've done up until now. Note that previously functions could also be directly edited from here. That's still possible when using the in-process worker model, but as we know by now, that is being phased out. To test a function, we can click Test Run. This allows us to specify the method, the key to use, say the function key, and we can easily pass through query parameters, headers, and a body for testing. For example, let's pass through search for with value Paris. And let's run this. And there we go, we see the response code immediately from inside of the portal and the response content, Paris. What's also interesting is that down here we see our application logs, and that includes the query that is being sent to the database. These are the logs that are also collected by App Insights. If we don't want to see the App Insights log, but the file system logs, we can choose that as well, and we can also choose the log level if we need. All of this is related to the request we just sent, so this is very useful when live testing a function. However, when you go to invocations here, you can see the invocations of this function in the last X amount of time. You can see that I've hit quite a few errors when testing, and I've also hit quite a few successes while testing. Let's click one. From this page, we can see all the invocation details, and we can then go ahead and run this query in Application Insights, which automatically gives us a query that returns the same invocation details, but with more detail. I detailed how to use Application Insights in the Getting Started course. That knowledge can be applied here as well. Back to the function detail. Via the Logs tab, we would see the same logs as we would see in the window down here. And via the Metrics tab, we can get a list of useful metrics related to this specific function. This is in fact very much like what I detailed regarding metrics in the Getting Started course, but this time it is scoped to this specific function endpoint. So, all in all, you've got a vast amount of ways to monitor and test Azure functions. Most of it isn't new, and that's a good thing, because it nicely integrates with Application Insights and the Azure Monitor service, which means that if you know how to use this for one type of service, you know how to use it for another one as well. We learned a lot about Azure functions by now, and while they're pretty great, they also have a few shortcomings. A regular function is designed for short-lived stateless operations, typically event-driven. We used processing an HTTP request as an example. But sometimes you may need more, longer execution times or statefulness. That is where durable functions come into play. Durable functions are a feature of Azure Functions. They enable stateful features with a longer execution time, which also means they support complex orchestration patterns and can be used for tasks that require state management and or coordinating multiple functions. You're looking at a table from the beginning of the section in which I compared both approaches. But what are good use cases for durable functions then? In essence, all of them come down to enabling stateful coordination in an easy and convenient way, but in serverless apps. There's a great page over on Microsoft's documentation where a few application patterns are described for which durable functions can help. You can find that via the URL on screen. A common pattern is function chaining, in other words, flowing from function to function. That requires state management. Seeing a regular Azure function is stateless, it would mean you'd have to resort to some other way to store that state. For example, store the output of function call 1 in table storage, pick it up when starting function call 2, store the outcome of function call 2 in table storage, pick that up when starting function call 3, and so on. That's annoying, but that's just the easy part. Imagine having to implement a retry policy here, or automated coordination of function calls. Durable functions make this much easier. You can define an orchestrator function to manage that flow. Due to the fact that it has a way longer execution time than a regular function, this can be reliably used for chaining. We will look into an example soon. The fan-in, fan-out pattern is related to that. This means executing multiple functions in parallel and waiting for all functions to finish. Potentially, you would then do something with the results of all those function calls, or not. This too requires state and support for longer running processes. Async HTTP APIs are commonly used as well. This is the typical fire a request that's long running through some sort of trigger endpoint and then let the client regularly check the status via a status endpoint. The fact that this is long running alone makes it a bad candidate for a regular function, but this can be achieved with an Azure durable function. There's more, like the monitor pattern, which is again a typical pattern for which you need long-running tasks. You'd regularly poll an endpoint until a specific condition is met. Human interaction is also a very common pattern. Imagine an automated workflow in which you need approval for an invoice if the amount in the invoice is higher than a certain amount. Here, too, the fact that durable functions can be long-running and wait can help. And there's more patterns where this can be helpful. The aggregator pattern, for example, is in the documentation as well, but there's also patterns that are not detailed on this page. But I think you get the point by now. They all require some form of state management, a long-running process, and or orchestration. And that is what durable functions are for. Let's have a look at an example.